Oh, well, hello. Well, hello and welcome to my YouTube channel. And I'm hoping that you're well. And so I have come with yet another video. And this time I have taken up a problem from British Mathematical Olympiad and from the previous year. Uh, why I sort of like British Mathematical Olympiad is because of its ability to ask questions which are not entirely mainstream. So, for example, the general kind of questions, if you have been engaging with mathematics, it just so happens that you get a hang of problems that are generally asked in these examinations. But British Mathematical Olympiad has a knack of coming up with problems which are typically nice. And in fact, might I add that sometimes these problems are obviously mathematical, yes, but it tells you that there is some area of mathematics, or there are some areas which you have to really think about in order to solve them. And you just can't rely upon the available templates to solve the problem. So here we take up this problem. So it says that, and this is one of those games, little games, and to be very honest, I'm terrified of games. And I distinctly remember one of the first early problems which I solved was regarding pebbles, and I just solved it down. So I solved it in the reverse manner, and somehow I got the answer. So much as I dislike solving mathematical games, but here we are. So this is such a nice game. So it says that Alex and Katie play a game on 8 by 8 square grid made of 64 unit cells. They take in turns to play the game, with Alex going first. On Alex's turn, he writes A in an empty cell. And on Katie's turn, she writes K in two empty cells that share an edge. The game ends when one player can't move, right? And so what it's Katie's score when when game is what's the maximum Katie can score if she plays well, no matter what Alex does. So no matter how Alex does would mean that Alex is also quite rational, and he'd like to spoil Katie's chances of getting maximum squares filled or maximum unit cell filled. And an obvious idea would be that, not idea, but an obvious conclusion of this statement would be that you have to assume that both these players who are engaging in this game are absolutely rational, and they have got a strategy to sort of limit each other. So Katie must have a strategy to maximize the number of cells that she's going to fill, and Alex must have a strategy to thwart Katie's attempts at maximizing her score. And yet Katie would be able to score a certain amount of cells and should be able to fill. So what's that maximum score? Assuming that Alex plays at his best. That's what I have inferred from the problem. So obviously 8 by 8 is going to be a big task, and to be very honest, it's uh, so it just so happens that 8 by 8, I mean, sometimes it can be really difficult to conceive of an 8 by 8 square. For me, it was, in fact, because the possibilities are sort of endless, and you don't even know that what you're doing is correct, right? And just after first few, just of identifying first few things, it's very difficult to possibly indicate that this is what is going to happen. So what I'm going to do is that I'm going to do it first on a 4 by 4 board. So what I see here is that, well, these 4 squares are very crucial, and that's simply because these have only two neighbors, which they share an edge, right? You look at this, and this has got 3. You look at this has got 4. So these 4 are sort of crucial. And if I'm Alex and I'm going first, as the problem says, then I'd be somewhat circulating around these 4 squares. So I would rather Katie have not fill these cells, because if I can somehow come here and here, then this would mean that Katie can't fill this cell. So that's my fundamental attempt, right? So assume that I begin with Alex here, and Katie is a smart player. She knows that, well, I have to take many of these, and she goes about it. Well, she takes these. And then what I can do is that, well, I can take these if you like. And well, Katie being smart, and Katie will take another two corner. I don't know which one of them, maybe these, something like that. And then, well, it just so happens that I can take one of those. So if I take one of those, then Katie will have to leave at least one of these. Because if Katie takes these, she's bound to leave this. And if Katie takes these, then she's bound to leave this. And if Katie decides not to take any one of them, then, well, then you know that she'll have to leave all three, because in my next subsequent move. So let's assume that Katie takes these, something like that. Okay, right. So now it's my turn, Alex. And what I can do is possibly that, well, I have already sort of made this space unavailable, made this space unavailable. I can make this space unavailable by coming to this point. And when I've done this, then Katie will possibly take these two, or will take these two, no matter what she takes. You can always, and now I'll take one, and Katie has nowhere to go. Katie can't take these two, Katie can't take these two. So that's what Katie can score, and that's that makes a total of Katie's score as 8, if you like. I'll recommend that you should try this, and in more 4x4 such matrices, in 4x4 arrangements, and you'll see that if Alex plays with some strategy in mind, then Katie can't go beyond 8. And if Katie is smart enough, then Katie will go beyond, will take up at least 8. So my guess is that, well, 8 is the maximum score which Katie can achieve if both of them are rational players. And so in an 8x8 sort of arrangement, my guess would be that the highest score which Katie can muster is in fact 32, which is the half of total number of squares available. And so here it is. I've taken the liberty of taking up chessboard. In fact, you'll see that this is going to be very beneficial. So first of all, let's show that Katie will take up 32, at least 32, no matter what you do. So divide these 8 by 8, which is 64 by 64, 64, which is 8 by 8 chessboard, into 16 2 by 2 squares. Okay, good. Yeah. Now think about it, that if Alex takes any one of those, so Katie can take 2 positions in this 2 by 2 square, right? And if Alex takes any one of those other position, Katie can take 2 position in one of these 2 by 2 squares, right? If Alex takes this position, then Katie can take any one of these 2 positions in this 2 by 2 square. You could definitely argue that what if Alex doesn't hop from one 2 by 2 square to another 2 by 2 square? So for example, what if Alex takes this one, then no matter what, Katie can still take 2 positions in one of these 2 by 2 squares, right? So at least Katie has got 16 moves with her in these 2 by 2 squares, and she will have 32 squares that she can occupy. And that's simply because there are 16 of these 2 by 2 squares, and no matter where Alex puts himself, Katie can occupy this this 2 by 2 and get two squares for herself, right? So that's one. So Katie will score at least 32, and we are not saying that, and that I'm not at all claiming that that's the end. So after 16 moves, it will be end for Katie. No, it's entirely possible that Katie might be able to amass more score than 32. But then in that case, I'm going to believe that Alex didn't have a nice strategy to sort of thwart her score. And assuming that Alex is also a rational player, now I'm going to argue that Alex can do something that will sort of necessitate that Katie can't go beyond filling 32 unit cells. And now think about it. So if Alex is a bit smart and Alex takes up same colored squares, so if I'm Alex and I'm going to take up these and these and these and things like that. What Katie does, every time when Katie takes up two consecutive squares, we realize that Katie takes up one white and one black, right? And if I'm Alex and I'm just taking up white squares, then in 16 moves, I would have occupied 16 white squares. And in 16 moves, Katie would have occupied 16 white squares because these two adjacent, one of them has to be white. So which means that in a total of these moves, we have already occupied 32 white squares. So the remaining squares on this board are left only black, and Katie can't possibly take two consecutive, two adjacent, if you like, squares which are of the black color, which means that Katie will have to stop, and she can't go beyond any further. So, well, the maximum score is 32. And we're done.